time with loops because I'm still having students that aren't quite understanding outer loops. Maybe they get the inner loop from the test, I could tell. But that's another thing I'm going to go over. There's a couple of the different ways y'all did the test. I didn't look at Robert's. I don't. You're Robert, right? Yeah, I need to look at yours because you got done real early too. And Piers, I didn't look at. The only one I got a chance to look at, so I may look at the ones that are here today, so we can kind of see how everybody did it differently and learn from that. Okay, so that's what I want to look at first. I did do Luke's. That's what you, right, Luke? I did do your test, so let's look at yours and see. I think I still have it open. No, let's see.
Trying to remember when the test was over.
Yeah, I'll read the problem first, and then we'll go from there. Let's see. Yours was T. Thought it was called T3. Well, it must have not updated my Google Drive when I download. Oh, I'm at the wrong class, right? Because y'all are 8056. That may be what it was. Let's see. Let's look. No, I'm in 8056. Maybe I put it in the wrong folder. Let's see. We're 8056. That's what I did. I put yours in the wrong one. Okay, I don't want to go there. I want to go to 8056. All right, now I'll have it in the right one. Okay. Now, in this one that Luke did, he used a do while, which you're not expected to know how to do it, but he looked it up because he was having trouble with something. So let me read the problem first so we make sure. This answers it just a little bit different, but I thought it was an interesting way to look at it. And that's the idea here, is I want y'all to come up with, as long as you get, you know, a viable answer, that's what I want. But in this problem, you were going to take what was in test problem number 2, which was just if-else's. And some students had trouble. They were getting trying to put loops and if-else's together. But actually, all you needed to do was encapsulate what you did in test 2 as part of the outer loop. Okay, the outer loop was the whole problem. And so that's what this first part was. And in the second part, what I asked you to do was your nested loop was to test the GPA for validity. And so you had to each time, and I gave you the function in JavaScript that works to test it if it's a numeric. And so that loop, all it needed to have in it was the while, and then, okay, that's not valid, enter another one. So it needed to be a prompt or a document.writeline and a prompt, whichever way you understood it better. And then I gave you the steps here, I think. Oh, this must stop. Oh, this isn't my newest one. I opened the wrong one. File. Because I did go in, and I think in you all's is the first one where I gave you the steps to go through, and because students had so much trouble on Monday. Let's see, where's that at? Test 3. Okay, there it is. So if you followed the exact steps that I gave you, you should have, what in the world, been able to get the logic correct. And that's what I wanted to see, even if you never got the JavaScript to run. But for some reason, my PDF isn't wanting to open. Come on. There it is. All right, so here's what I gave you. I said, where is the one with the steps? Didn't I give you all one that said steps, do this, this, and this? I think I did. Now I'm not able to find it for some reason. Maybe it's this one. Maybe it's this one. No, that one's not doing it either. Okay, I'm going to take the one that was inside D2L and go from there. Let's see. I don't want this. Oops, I don't need that. Okay, so inside D2L here, I gave you one. It should be. That's crazy that that's not my current one. Okay, 8056. Oh, I know what it is. All the news items have to show up. Here it is, test number. Yeah, here it is. Okay, on the hint, what it says is start with the priming input. And I guess when I use that word priming, some of y'all didn't remember what that means because you only need one input. That's the priming input is going to be the one that is tested in the while loop to see if you quit. So what variable was that? What variable did I tell you to test for quit right here? It says to allow for users to input students until a quit is entered in the student's name, right? So that's the only input that you needed prior to starting the loop. So let's look at this one. Where did it go? So here's, now you did yours a little different from that because you said, and somebody else did this, instead of doing their priming input here, what he did is he set up a constant and named it GPA check, but where did you initialize it? Right here. Okay, so when you actually came into this loop right here, there's not, you put Ray J. Johnson in there so that it would not say quit, right? Would not quit on him. So instead of doing a priming input by doing a prompt, he did it with a constant. So he still primed his input. In other words, priming, it's like priming your engine in a car. That's what they call it. It's priming. Means you got to put something in it. You got to get it going. So to get that name to have something in it before it hit this while loop, he used a constant. What I was wanting you to do was say prompt equal or name equals prompt and get them to put the first name in. Okay, so then by doing it this way, he said, okay, set GPA check equal to 1, and he was using a constant all the way down to find out if it was a valid GPA. He did more than one validity check. So here he went in, and this is really his first time to ask the input, and he used a do. So it does this, then while GPA is not a character, it'll stay in this loop. But let me show you what it does when we run it. Okay, then it should drop down here, and when you enter a valid one, like say I entered 1.9, well, it's less than 4 is less than 1.9, so it will do this. Please enter a valid GPA, right? Is that what it did?
That one is for like the GPA can't be negative or greater than 4.
Okay, so, and this one is 0. Okay, so that's saying if it's
If it's negative.
If it's
then
negative,
prompt.
okay.
And if it's greater than 4, then prompt.
Okay, so he's checking other validity besides just is not a character. He's making sure that it's not a negative number or greater than 4, right? Okay, so if we run this one, let me show you what happens. It works. It just makes you, okay, see I should have enlarged my screen. Let's say CS. Okay, if enter the GPA, let's say I put a B in there. Please enter a valid numerical GPA. Well, if I say 1.9, it should go ahead the way the problem read and print out my Donna CS and that this one is on academic probation, right? But what it does is it goes back and asks student name again. Okay, but I still counted it right because that's just another way of thinking about it. So then the person, if he would have said here, okay, re-enter the student name, because it took him back where, okay, now I have to assume that I need to enter that same person again, but this time I'm going to enter a valid GPA the first time. Then it does it correctly. Goes to 1.9. And then if I enter quit here, it does work. The loop quits. Oops, was it there? It was supposed to quit. I did it a while ago and it did quit.
The prompts are supposed to be outside of the student.
Okay, let's see. And this one should say QUIT and it should quit. Okay. So that was one way that it was solved. And let's look at a couple of others. Let's see. Robert, I am Piers. I want to look at y'all. Did you get yours working, Rodrigo? Okay, we'll look at yours too. Oh, you weren't here Tuesday. Okay, you didn't do it. All right. Amanda, Aaron, Alec, where is Robert? Is here. Follow the hints, Robert, a little. Okay. Let's see. Oh, I remember I'm having trouble with my screen. Let me do it this way. Now I'll save it. Okay. Okay, so here's the way Robert did it. He got his 3 variables, initialized GPA to 0. Okay, you made Dean an actual literal and probation a literal. So you probably used your test 2 answer. Is that what you did? Okay, no problem. All right, so then he also used constants for the high, the Dean's GPA and what it has to be for probation. And then instead of actually typing out the prompt, he made a constant for the error message, right? And there's quit and break. Okay, so here's his priming input, which is the hint that I told y'all to do. So the first time you enter into his while loop, it's going to have a name in there. So it won't be equal to quit. Then major equals, then he prompts for the major and for the GPA and prints those 2 out. While is not numeric or, okay, and you did the same test like Luke did. Luke, did you see how he tested for all 3? So he tested for all 3 with ORs. So he did the is not numeric, if it's not numeric, or if it's less than 0, or if it's greater than 4, then prompt for the GPA again. And he prints out this message up here because he made his a constant. Okay, then grade point average, print it out if GPA Dean. Okay, so you used another compound or here. Document.WriteLine. And then here is the input that some people kept missing at the bottom. Because once you do your outer loop, at the very bottom of your outer loop, before it goes up and asks if it's equal to quit again, you've got to get a new value into name. Okay, so let's see, has run. What is the student's name? What is student's field? What is the student's current GPA? Okay, let's put an invalid one in there first. And it says you have entered an invalid number or character for GPA. Please enter a valid one. So if I put 1.9, it printed due to the student's poor academic performance, they're on academic probation. Good job. Okay, so what is this next student's name? Okay, let's name him Frank. Political science. Let's say his GPA is 3.8. So there it printed out that they're on the dean's honor roll. Then it says enter quit to quit. So if I quit right here, and it does stop. Okay, and he put a background. That's a HTML code he looked at. Very good. All right. Any questions about how Robert did it? Bayhat. Okay, we got one more. Rodrigo. Oh, and Nick, you did yours too, right? Okay, we'll look at both these, then I'll go in and give y'all your grade. Let's see. Oh, and David's not here today. He's always here. Test 3. Okay, and this one's your HTML, right? TRA, open with. I don't even do the pseudocode or flowchart. As long as your JavaScript runs, then I'm assuming that your logic in your pseudocode or flowchart's correct. So, okay, so Rodrigo, he followed my hints. He put the priming input, then the while, the other inputs, output all of them. Then he just tested all that I required you to do was to test if it's not numeric. And then this is the test 2 that you should have done. And then here's the prompt at the end. Very good. That's real straightforward. That's every time you do an outer, you can make sure that your outer loop always has a priming input. Then you test the while, and then whatever else you want inside the outer loop. But at the bottom of it, the very last step should be priming that input again, okay? If you do that on every outer loop, what you put in the middle doesn't matter, the loop will work, right? Okay, so let's run this one. Please enter your first and last name. Major field. Please enter GPA. Okay, let's test his is not numeric. And it does say, please enter your GPA because it was invalid. So then if I put 1.9, there's academic probation. Okay, let's do okay, and a valid for 3.8, and there it is. So let's do quit. And oh, I did do what? Oh, you got to enter stop. Okay, I didn't read, did I? Okay, let's see. GPA, do 3.0. Please enter your first and last name or stop to quit. Yeah, that's what he told. Oops, not caps either. And there it stops. The only thing that you might want to do on the next one is put breaks in so that it'll just the output looks a little better that way. But your logic is great. That's exactly the hints that I gave you to work that way. Okay, Nick. Everybody that I've done, get all the points here. Let's see. Nick's, where's your Nick Rock? There it is. And Rick, did you get yours to work? You did? Okay, well, we'll look at yours too. We won't get as much as chapter 6, but I like to do this so y'all can see all the different ways of doing the problem. Because remember, the final test is going to incorporate, actually, I've decided I may give one before the final just to test arrays or functions, because functions are pretty easy. And we may give one more just so y'all have a chance to, and what I may do with it is it can make up one of your others, and the final can make up one of your others. Because I think it'd be easier that I test a smaller one with arrays before we do the final. Let's see, T3. Okay, so Nick did the same thing, except for he did a little bit of the constants, like you used your test too also, right? Your own, right? That's a good thing to do. Then here's his priming prompt input. Then he tests his input with his while loop, gets the rest of the input, tests for a not numeric GPA. Then this was what was part of his test 2 already. And so the only thing he had to add was at the bottom.
Yeah, I didn't enter the enter quit part. It's just the.
Oh, you never got the, oh, I
Yeah,
see what
no,
you're
I
saying.
mean, it works if you enter quit. I just didn't get the prompt to enter quit. It's a
So,
secret. You have to know to
oh,
quit.
oh, because you did document.writeline. Okay, so it works. Let's see. Please enter your name. Please enter your major. Oops. And your GPA. So if I do your entry is invalid, try using numbers. Yep, you're better start your work academic. Okay, and you didn't print out the name and
No, I forgot. I used test 2 as a base, but I didn't
go back and put that in
I
there.
didn't use all of it.
Okay, please enter your name. So this one is where you can enter quit. You say, well, I'm gonna do one more. Let's do and a GPA is 3.8. And now I can quit, right? Yep, there it is. Okay. All right. So the only thing that he would have wanted, like he said, to add was down here when he, is this, where's your, oh, right here. In his prompt, that bottom one, he needs to say, or quit to quit. And that's the only thing that you needed to add to it. So that's good. Good job. Okay, so let me go to Enrique's. Am I saying your name right? How do you say your name?
Well, everybody says it different.
And so you're not particular. That's awfully nice. Some people are real particular about how you say their name. Okay, let's see. This one is here. Okay, now is this one yet? Okay, now it probably doesn't run in HTML unless you named it HTML. Let me see. I probably need to. Yeah, let me see if I can save it as HTML and then it should run. Did it run like that? With Java at the end? Really? Wow. Let me see. How did I get it? How did you get it to do that? Okay, let's see. Yours was called T3EC. So when I open it, you must have been doing it in a, Oh, it opened it in Xcode. Huh. Let me save it as an HTML and it'll run it in. Then it'll let me open it in. Oops, HTML. Okay. Okay, let's look at this one. Yeah, here we go. So you've got, yeah, you followed the hints. But if you save it as HTML, it should, yeah, please enter your full name. Please enter your GPA. Let's see if we enter invalid. It did enter invalid. So there's 1.9. Good. 3.8. All right. Good job. Okay. So now, is this Aaron over here?
Yeah.
Did you do yours?
Yeah.
It ain't right. Okay. So we won't pull it up yet. All right. So I'll look at it and we'll see what we need to do. Oops. There's what I need to do. Okay, so I'll go back all those that I graded in class. Those are all good. So let's see what we want to do then. I was going to maybe go over some more loops, but I will, what I want you all, if you're having trouble with loops, we'll go back and go over like problem 8. I think I did it in one of the, I gave the answer to it. So if you're still having a little trouble with the outer loop and the inner loop, you can do that. But what I want to go ahead and start on, let me look at, show you all the schedule for next week and this week. Oops, where'd it go? Oh, I'll just do it from up here maybe. So if we look at Evernote and see kind of where we're at first. If you go down, we're actually in week 11 this week. And so what we're going to cover a little bit, we won't cover all of these examples that are in this file, but I give you a zipped file in Evernote that you can download that has some examples of chapter 6. And we're going to cover part of chapter 6, but we're not going to cover, tells you here, where does it go? We will only cover overloading in class, but there will be no problems assigned that require overloading, because whenever you get to Java or C++ or C#, you make sure you know the terminology, which you'll, in that quiz, reading quiz over chapter 6, it'll have a question on overloading. Overloading's on page 232 in your book. So what I'm saying is, we're going to cover it in class, but you won't have any problems that you have to code in overloading. That's called polymorphism. It's a little bit more of a advanced object-oriented class. Part of the object-oriented programming. Also, there's a section in chapter 6 about using arrays, and we won't, because we haven't covered an array yet, we won't be able to do a problem on it until after we do chapter 5. But if you look in the Evernote here, what I want you, what I want you to have done by when we have class again is have taken the reading quiz, because it's due by Sunday night, November 3rd, okay? So that I know when you come back to class next Tuesday, you should have read chapter 6, okay? And I'm just going to give a brief overview of it today. And then I also, what I want to go over is I want to go out actually to W3 Schools and show you the JavaScript tutorial on objects and functions. And I also gave you a link to Code Academy if you wanted to play with it in JavaScript. It has a link there to functions in JavaScript, and that's what chapter 6, they call it using methods. It's also sometimes called functions in all the languages. But what you do is you actually modularize, my tongue's all messed up today, modularizing certain sequences of things that you do. For instance, when we inserted that test number 2 section in test number 3, we could have made that a function, and then it could have been called instead of having it in the main part of our program. And that's what all of chapter 6 is about, is modularization. So for the first part of chapter 6 work, if you'll look in Evernote, it says page 245, do problem 1A and B, pseudocode or flowchart, and then JavaScript will do A in class together, and then I'll have you do B. So by next Tuesday, if you've done 1A and B in pseudocode on page 245, we'll do 1A in JavaScript, and then I'll assign for you to do B in JavaScript. And then the only other part to this chapter that you'll do is down the second thing in week 2. And it tells you exactly, but we're going to do that in class too. So here's some of the examples, but first of all, let's go over some of the terminology on page 205, understanding the advantages of modularization, because all of these terms is what will be in your reading quiz, okay, that are in black bold print on page 205. So first I'm going to call up the PowerPoint here for chapter 6. And I think what I do here so that it turns out right on my recording is I have to kind of just make my screen a little bigger. All right, so using methods, there's the objectives for this chapter, which are on the first page, tells you what we're going to learn in this chapter. And what we're going to talk about overloading methods and using predefined, but we're not going to, and we actually have already used a predefined method. What have we used? We've used 2 different ones. What predefined method have we used in JavaScript? You just used it in test 3. What was it? Oh, he's got his earphones on. Come on, take your earphones. So what was that one we used that I gave you to use, that you tested the GPA with? Not number. If it's not a number, that means predefined because you didn't code it, right? It was already part of JavaScript. So there's tons of those out there. What was the other one we used to make our output look good in if it's a numeric field? I mean a money field. To fixed, right? So there's a lot of those out there that we can use. And so we actually already did this section because we've already used predefined methods. Then we're going to talk about overload methods. We're not going to be passing an array into a method yet, but then, in fact, we don't even do that in our final project. But methods that return a value, we're going to do that. Methods that require parameters, declaring local and global variables and constants, modularizing a program, and the advantages of modularization. That's what we're going to talk about first. So modules, all they are is smaller parts of a larger task. So if you have a task that, say it's a program that's 2 pages long, well, there will be little procedures within it that you could take out and code and just call to that section. And so if you modularize or pull parts out of a program, then what happens is you can use those procedures in other programs. So we're going to see some programs where it'll make a little more sense.
Is this like macro programming? Or?
It could be something like that where, yes, if you have something that you do over and over, that's what you're talking about in a macro. You do steps over and over. Well, if you make them into a function, then in your main, all you have to do is say, maybe there's one where you square a number all the time. Well, you could make a call to that and come back to your main, because every program may do something different afterwards. But then you've got that catalog that you can use. And here's some different names that modules are given. Sometimes they're called methods depending upon the language that you're coding in. Sometimes it's called subroutines. The first language I ever learned was COBOL, which isn't hardly used anymore. But they called their methods subroutines, okay? And then there's functions, and that's what they're called in C++ and Java. A lot of times they're called functions. Some languages call them procedures. So they're all the same thing. They're just small modules, but they just have different names. The advantages of modularization, are that it provides abstraction, simplifies the logic, allows multiple programmers to work on a problem, and allows you to reuse work more easily. Like when I was in programming, we always had project teams. We had systems analysts that would give us a project, and the team worked on it. Well, it was usually a massive program. So they would say, okay, you work on this part of it. This person's going to work on this other part. And then when we get those running, then we can put it all together.
It's more like actual. That's how they do it in like when they make the Word or something like an actual program. That's how they
program it, right. And here in our book on page 205, it gives us an example of abstraction. It's the process of paying attention to important properties while ignoring non-essential details. So abstraction is selective ignorance. That's kind of funny the way they're putting it. Life would be tedious without abstraction. For example, you can create a list of things to do or to accomplish today. You can say, do the laundry, call Aunt Nan, start term paper. Without abstraction, the list of chores would begin. Pick up the laundry basket, put laundry basket in the car, drive to the laundromat, get out of the car with the basket, walk into the laundromat, set the basket down, find quarters for the washing machine, and so on. So that's like the examples that Piers was giving us about the peanut butter and jelly sandwich. You can put on your list, just make a peanut butter and jelly sandwich, which is the abstraction part of your list. But the tedious part is the part that you want special modules to do. Because then, have you ever been around a person like, I know my daughter, I've homeschooled my children, and my daughter that's 16, she was totally different than my son. When she wanted to know what to do, she just wanted me to tell her, and then she would figure out the details. Well, I always wanted to sit there and explain to her, this is how you do this. She'll say, Mom, I got it. Mom, I got it. If you've ever been around people that are real detailed, they're usually teachers, and they want to tell you every little thing. Well, really in programming, that's a good character quality to have, because you have to recognize the details, and you have to code the details. But when you're just trying to solve the basic problem, you just want to put the steps down like you did on the to-do list, and then assign a programmer to write the module for doing the laundry, another one to write the module for calling Aunt Nan, another one to write the module for starting the term paper. Make sense? So that's what modularization is, being able to get other people to do those tasks. So here's the one that explains modularization, just what we did. Then all computer programs provide some level of abstraction. No longer do you need to understand the low-level computer circuitry instructions to write a computer program. But like when I was telling you when my dad started, you had to understand what the electrical engineering people understand. You had to understand the circuitry of the computer board to be able to program it. You had to know the registers. You needed to know assembler language, which still wasn't machine language, but how to access. You didn't have variable names. You had to access the register where that variable resides, and you had to say, put this in it, then do this, okay? So now, because of the advancement of our computer languages, you don't have to know all of that abstraction that you used to have to know. So with modularization, the individual methods are smaller and easier to follow, and errors are easier to find. When I started programming in 1979 for the State Tax Commission, first program I was given, they didn't do modularizations. People in programming back then, very few of them had formal education. And so when they wrote a program, it was called spaghetti code. It would just go down and down and down. Then they might say, go to here, and then go down to here. And you had to figure out how they were coding that because they didn't have any kind of structure or any kind of modularizing and putting steps out here where you could go from the top to the bottom in a logical way. It was very difficult. And that's why more formal programming helps you to be able to code behind somebody else. Okay, and a lot of times your first programming jobs are to go in and modify what somebody else has done. Very seldom, unless you have your own business, do you get to start from scratch writing a program. Okay, so you have to think like somebody else thought, and that's really difficult. That's why I like to show you all the different ways that people code. Okay, methods are to execute a single finite task, and smaller methods are less complex and therefore more reliable. So if you can get those little modules to run, then put one module in, the main one at a time, then it's easier to find where your errors are. So we already talked about this. Multiple programmers can work on a problem. Modularization, C++ is actually the first language that let you catalog different methods and functions that people wrote, and they stored them in a library where they were predefined and you could use them. It was reusable. But when I coded in COBOL and we started doing that, we would store our stuff where we knew that it was something we had already written before, and we'd copy and paste it.
So like on C++, is that part of like whatever program you use to write that?
C++ actually has a library of predefined functions, and you can call them from that library. Do this and do that. And see, that's how JavaScript, that's really what we were doing with that is not a number and the two fixed, is we're calling them out of a library of code, and that where they're already coded.
Is the document right?
Yes, it's a method too. Okay, so reusability and reliability, those are some other things that modularization help us with because they've been tested, so they're reliable functions. So in the application classes, they contain a main method. The main method is the one that encapsulates all the calls to the modules. And that's why in our book, they always have, like on page 209, the flow chart, and the pseudocode starts with a main, because that particular method is the one where you put all the others inside of it. And most all object-oriented languages have a main. That's how you start the coding. Just JavaScript doesn't make us do that. Parts of a method is that it's going to have 3 parts. It's going to have a header, a body, and a return statement. So you'll notice in our main method, that's actually the header, but there's not any parts to it other than the two parentheses, the open and closed. That tells us that it's a method if it has a name and an open and closed parentheses after it. That tells us it's not a variable name, but it's a method. And then the body are the statements that you do inside that method. So the example they show us on page 209, the declarations of our variables, the input, output, those are the body of the main method. And then it has a return statement at the very bottom. And that means return back to the top of main if you're going to loop, but there we're not. It just says return. And class, the reason they use that terminology in our book is because in all the object-oriented languages, they're really not called programs. They're called classes, and they're stored in the library that way. To use a method, you call the method using its name. So the flowchart conventions for method call symbol is a rectangle with a bar across the top. So if we go over to, I think it shows it, yeah, and page 210, okay, what they've done here is they've created, there's a problem. The example, it starts on page 207, a header. The method header includes the method identifier and possibly other necessary identifying information. So and then the body is the method body, then the return statement. But within the program, if we want it to print out, like for instance, if you look over on 210, what did they do in that flow chart? Let me see where that is. Here's the one that is just straightforward. The main, it has the variables, input, output, and then outputs the address, then stops. But if you go to the next one, what have they done here in this flow chart? And if you can't see mine, it's on page 210 in your book. What they've done here is they took what was in the middle of the program, the printing out the address, and they pulled it out, and they called it display address info, right? So how did they call it? Well, in your flow chart, it's done with a rectangle with a line across the top. And that means go to a routine or a method called display address info. So you go over here and it outputs those three statements, then it returns back to the statement right after where it called it. You understand that code there, the way the figure is? So all it did was it simplified the main, made the main shorter, and extracted those few statements there. That's called encapsulating. You see that over on page 211, that term. So a potential drawback to creating multiple methods and moving between them is the overhead incurred. After executing a method, the computer keeps track of the correct memory address to which it should return by recording the memory address in a location known as the stack. But you don't see what it's saying is, okay, your computer language, whatever you're using, if it's C++, in this case, we're going to be using JavaScript. When you exit this main program and go over here and do this, and it says return, it stored this information of where it stopped. And it comes back to that location and finishes the program. Make sense, or is it real foggy? You have a question or not know what to ask yet? So if we were, now this is explained there on page 210 and 211. And so what we're going to be doing is we're going to be writing little routines and pulling it out. I'm going to have, let me go here because we've got a couple minutes here to do this. I'm going to view this little short clip that the author does for this chapter and see if saying it a different way. Watch modularizing. Okay. I know she has a different. See if y'all can hear it, I think.
Hi, this is Joyce Farrell. Let's look at modularizing a program. Here's a program that produces a customer bill. The program starts and you declare some variables. Then you input a customer's name and balance due. Then you're going to output the address of the company. So you put the company's name, street address, and city, state, and zip code. Then you're going to output some customer data. So you output the word customer with the customer's name and the word total with the balance due. That's the end of this simple program. You can take the statements that output the company name and address and remove them from the main program and place them into their own module. That module will be given a name, such as display address info, and end with a return statement. Then the main program can simply add a call to the module. So now when you execute the program starts, you declare your variables, and you get the name and balance. Then you call the module. Logical control leaves the main program and transfers to the module where the steps execute one at a time, outputting the company name and address. When the module reaches its return statement, control transfers back to the main program where the final steps are completed. The customer's name is output, as is the balance due, and then the main program ends. By putting the name and address steps in a module, you've made the main program shorter, you've made the main program perhaps easier to understand, and you've gained portability. You can now use this module in other programs in your organization. Thanks for watching.
Okay, so what I want to do before we go on to the next part, we're not going to go into the next part today because I want to get just this one part in your head. I want you to see how this works. So we're going to go ahead to your assignment and we're going to kind of talk about it together in class. We might do some of it. So if you go over to page, let me get this out of here. If you go over to page 245, and I'm just going to bring up let me bring up a Word document here. I think we'll just do it in pseudocode first so we can see this. Let's make my stuff a little bigger here. Oops, I don't know that language. UV Verdon. Okay, and I make it like about 18 here. All right, so in our exercises, it says, number 1A on page 245, create the logic for a program that calculates and displays the amount of money you would have if you invested $5,000 at 3% interest for 1 year. Create a separate method to do the calculation and display the result. Okay, so we're going to have input first, right? We're going to have variables. So we're going to start our program, and first thing we do is our declarations, right? So what variables do we need? Okay, we're going to need, actually, do we need any input variables? Create the logic for a program that calculates and displays the amount of money you would have, because it's not asking for how much you invest or what the percentage is. So what are those? They're going to be variables, but they're going to be constants, right? Because it's given us a constant. So for 1 year, so all we're going to have to define is amount. Does anybody have any ideas? I'm going to go over here and get back to this. Where's that at? False. Okay. Make sure that that's not it, I don't think. And this one, I think I may have put this one already in. Okay, so I would rather look at this flow chart so I don't have to try to draw a flow chart. Let me get it in where it views like 200%. Okay, so what we've done is declared num principal, num balance, and interest rate is 3%. All right, so then the principal, it tells us, is equal to 5,000, right? So it already told us that. So we could have actually made it a constant up here. We could have said principal equals 5,000. Then here's where we pull out the actual routine. Compute balance, principal, and interest rate. Actually, that one is going to be what we haven't covered, where you're sending parameters. So let me look at one of these other examples, because we haven't covered how to do that yet. Examples where I have you download the, I gave you the examples for chapter 6. See if I can find where chapter 6 examples. There they are. There should be one in here that just does a return. Let me look at this one. I want to do that first before I get you all confused about that. Yeah, this one's a little, this one doesn't have, oh, it still has you do that. Okay, so what I was trying to do was get one where you didn't have to know anything except displaying. So all we're doing in this particular one, is displaying what we went down the steps and then we pulled it out and just displayed. We didn't send anything into the function. You see in this one, what we're actually seeing here is that the name of the method here is what? What's the name of the method? Compute balance, right? But what's different in this one in a display address info? There's something in the parentheses, right? We haven't covered that yet. Okay, declare right on the next page is declaring local and global variables and constants. Okay, so in this one, they did not. What is the motivation? Oh, that one's okay. That's the one. Okay, on page 214, this is what this one is. This one says creating methods that require parameters. It's an argument or a parameter. Anytime you pass something into the function, it's called an argument or a parameter. And that's what they're doing in number 1. If you try to do number 1 in your textbook, this is how it should look, because what they're doing is passing. Okay, this is called a global variable because it's declared in the main. It's not declared just inside the method. This one's called a local variable because balance is not known back here in main. Make sense? It's declared inside this little method. So if you tried to refer to balance here, it really wouldn't work. They're using it here, but it's not known here. Let's see why they declared it here. I don't know why they did it up there. That doesn't make sense. Because what they should have done, because see here, their output after your balance is balance. If they tried to print balance out here, It wouldn't know what balance is. See what I'm saying? Because here they declare it, but they don't ever give it a value. So down here they say, okay, let's go over and call this method and let's send over there principal. But look, they defined it over here as a variable paren. So whatever's in principal is going to go into this variable named paren, and whatever is in interest rate is going to go into this variable interest when they call that method. And so then they have to make one more declaration, which is balance. Then balance is equal to paren times 1 plus interest, output balance, and then come back to the return. So there's nothing they do after they come back to the main in problem number 1. Okay? Do you guys see what they're doing in this one? This is your number 1A. You may figure out a different way to do it where you make a method, but that's what this one does. So it calls it. And then we will do the JavaScript for this one on Tuesday. Okay? So what I want you to do is see if you can read through, when you read through all of chapter 6, that we didn't get to cover today very well, 214 and 215, is what you actually use in order, the example where's this one at? This one actually uses a loop too. Display address info balance on page 216. It is one where it's passing balance into the method. And what you'll notice is the variable name in the main is not the same variable name that it is in the method, but it knows to put it into that one. You also might be able to look at, let me see, I think she has, yeah. You can also watch the author's video, like it refers to on page 222, methods with parameters. And that'll may explain a little bit better about that. Okay. And matter of fact, let me just play it. We got 3 minutes. I'm going to put it on there because I know y'all probably won't open it and play it. This will, where did they go? 14. Okay, so this is the second one, which is methods with parameters. And this is the one that goes through page 222 in your book. And this is what you'll need to understand.
Hi, this is Joyce Farrell. Let's look at methods with parameters. You can pass data to a method. When you pass a data item to a method, it's called an argument. A method can receive passed data. When the data is received, it's a parameter. Here's a program that calls a method. The program starts and you declare a string variable called code. Code is set up in memory. Then you prompt the user, full-time or part-time employee, and the user enters a code. Let's say the user enters an F. Method and send code as an argument. This display rate method receives a string as a parameter. So a copy of the code from the main program is sent to the method, and it gets its own local copy of the code. In this example, the parameter is also named code, but the parameter could have a different name. This method declares 2 rates for full and part-time employee pay rates, then asks the question, is the code F? In this case it is, so we'll output rate 1 and 1650 will be output. When this method ends, control returns to the main program and the local copy of code disappears. Then the main program ends. Methods can accept multiple parameters. You can pass multiple arguments to a method, and a method can receive any number of parameters. When you do pass multiple arguments, you have to pass the same number. If you pass 2 arguments, the method has to be prepared to receive 2 parameters. they have to be the same data types and in the same order. For example, if you pass 2 strings and then 2 numeric values in that order, then the method has to be able to receive 2 strings and 2 numeric values in that same order. Here's a program that passes 2 arguments to a method. It starts, and we declare a bank balance and an interest rate of $100 and 0.02. Then we pass these 2 values as arguments to a method. When we call the method receives 2 parameters, and it gets its own local copies of balance and rate with the same values as in the main program. This method has its own local variable, new balance, and the new balance is calculated based on the balance and the rate. Then we can output the past values and the calculated value, and the method ends. When the method ends, the local variables disappear and control returns to the main program. Thanks for watching.
So that one is just like, if you watch that, that's just like 1A that you have to code, right? So she showed you passing one variable as a parameter and passing multiple, okay? All right, you guys are free to go, and I will see you on Tuesday then. Have a good weekend. I closed out of this.
So I know what I did wrong.
Yeah, but I gave you, because that was good thinking. I want to see creative ways of doing it. But you see how the logic didn't stop when, I mean, it made him re-enter.
Yeah, the only thing that should have been within the do is the chat. The prompt should have been like immediately
Above there, okay. Yep, that's right. That was all that you missed. Yes, should be.
Which one is it? Is it the BS203?
Yes, should be the BS203.
Sweet.
You too.